Alright, so let's look at some difference quotients, what they are and how to find them. So to get started, let's say I'm gonna create an activity, or a few activities actually. Let's say we're gonna start out with a function. F of x equals x squared. So now my first activity here, or a little example here, is nothing about difference quotient yet. All I need is to evaluate and simplify. So with your given function f of x equals x squared, let's evaluate and simplify f of 1 plus h minus f of 1 and divided by h. So let's consider this problem entirely as an algebra problem, where at this point you are required to understand how to evaluate either a number or an expression into a function. Now, so the indication here is indicating that we already had the function f of x previously defined. So what it does now in this setup right here, what you need to do is you are going to take the function f and evaluating it at the input 1 plus h. So you have done many problems and examples about how we can evaluate an expression into a function that was previously given. And so in this problem, what I see is my function was defined to be f of x equals x squared, which does what it does is that it takes every input x, square the input to come up with the output. And so the same thing we're doing here. But now the input is no longer one simple x. What we do here is we giving the input being 1 plus h. But the function now says the function f is going to take the input and the input as the entire expression right here. So I'm going to have 1 plus h as one entire input, one entire expression as one input. I am going to square that according to how the function is doing with your input. And so now at this point we have produced for ourselves a perfect square expression. And now we can go ahead and FOIL out that perfect square right here. At this point I have to mention, you have learned quite a few different ways here. You can either FOIL out term by terms, or you can use the identity, the algebraic identity on a perfect square right here to FOIL this out. So I'm not going to explain how I can FOIL this out, but after we FOIL and simplify all and combining all like terms and simplified, we're going to end up with h squared plus 2h plus 1. And once again, if you're having a question mark, I'm putting a red question mark here. If you are not sure how I get from this step of a perfect square inside parentheses out into 3 separate terms right here, now check out many other videos of mine, or over on YouTube and over the web right here of how you can do this. But in this problem, in this example, I am assuming that everybody are already fluent with how we can FOIL out a perfect square. And so now back into my setup in the beginning. Now what we've ended up here is just what comes out from f of 1 plus h. Now the setup here is also telling me that after we have got f of 1 plus h, we need to also subtract f of 1. And so a separate evaluation problem for us. Now the function f of x given previously, I am going to substitute the input value 1 to it. So now at input 1, the function is gonna square the input 1. And 1 square, according to the operation, is 1. And so now, at this point, we are ready to make that connection here. The setup in the beginning was asking us to take whatever comes out from f at 1 plus h minus f of 1 over h. So what you can do now is I am going to substitute the h squared plus 2h plus 1 that we have found previously for evaluating f at 1 plus h. I am going to substitute that in place of my f of 1 plus h in this setup. So consequently, I'm going to have all that there inside a set of parentheses. Now minus f of 1. I am going to produce a minus 1 because 1 was the output value for f of 1. And so the setup say this is f of 1 plus h minus f of 1 and over h. So good common practice here is that for beginners, it's always a good idea that we start out with each individual piece right here, and then once we've had all the little components, all the little pieces, then we're gonna put all the pieces together in the bigger complicated expression. And now at this point, back into this current step right here, then what you're having here is an expression that involving the h variable. And so what I'm coming out with is going to be, I'm gonna go ahead and remove the parentheses. It's a positive sign in front of my parentheses here, so we can safely remove without changing any signs here inside of parentheses. So I'm looking at h squared plus 2h plus 1, and then minus 1, and of course over h. And you can see that most of the time I haven't done anything with that h in the denominator yet. And so now continuing with my expression, we can now start simplifying further for like terms. I have 1 plus 1 and minus 1 here being the opposite term. We can cancel that out, cancel those out, and we're looking at now h squared plus 2h over h. And then we can still simplify even further. So to simplify further, h squared plus 2h over h. Notice that we have a common factor h here in both of my terms in the numerator. Therefore, what I can do is I'm going to go ahead and factor out the common factor h in my numerator, and that would consequently give me h in parentheses. After I pull out my common factor h, my first term becomes h inside the parentheses, and my second term becomes plus 2, and then over h in the denominator. And once again, that h in the denominator has remained still all throughout all those steps until now. And so at this point, if you're looking at your very last step right here, then what you have in the numerator is a common factor with the denominator. And so now in the rule of algebra, you can cancel common factor from the numerator and denominator. And that now gives me in the next step h plus 2. And at this point right here, if we're checking with as far as the simplification process is going, now h plus 2, there are no longer like terms, there are no other like terms to combine. H and 2, there are not like terms, they are not opposite terms, there are no further common factors to cancel. So at this point I would call we came to the end of simplification. And so making that conclusion here, our starting setup that we've had. All right, so making our final conclusion, we have gone a long way, but f of 1 plus h minus f of 1 over h has found being equals to h plus 2 after some process of evaluating in and simplify. And so that's your answer. And now, as another practice on the same function, I am going to ask the same thing. Evaluate and simplify this next setup right here. How about f of negative 1 plus h minus f of negative 1 over h. And so in this problem right here, we can repeat the similar steps, and you can start, hopefully you can start doing your own independent work with me as well as I'm going through the steps. So once again, the function here was given previously. The function f is indicating that it's taking any input x and square the inputs to give you the output. And so what we have done earlier, we can do the same here again. It's never a bad idea at all to separate out the individual components. So f of negative 1, for beginners, for starters, it's never bad to do this. Let's do one individual work for here. F evaluated at negative 1 plus h is going to equal negative 1 plus h being square, because that's square is the rule of your f of x function. And back into the problem, f of negative 1 minus h equals negative 1 plus h all square. The following work is going to take you to h squared minus 2h plus 1. And once again, if you need clarification about how I've made that transition between the perfect square of negative 1 plus h in parentheses all square and turn that into the h squared minus 2h plus 1, find my other videos on YouTube or find other videos from other instructors on YouTube. Then there are plenty of explanation of how this was done. But here I'm assuming once again that you have already taken some courses in algebra and you know for yourself how to FOIL out a perfect square expression. And so here, and that's how so this is going to be the output, the outcome for f of negative 1 plus h. Now back into my setup right here, I need to evaluate another component, f of negative 1. So f of negative 1, the function says, the rule of the function says the input negative 1. But now see, use parentheses is always the best idea right here, because I'm going to use parentheses here and I'm going to square. So order of operation here is indicating that we need to square the input here, including the negative sign. So it will consequently turns out being your output has become positive 1. So this is the output for f at negative 1. Once again, all those three terms are here is the input of f at negative 1 plus h. So now back to the setup again. The setup says f of negative 1 plus h minus f of negative 1 and divided by h. So what we need to do is we are going to take our work previously for whatever comes out of f of negative 1 plus h. I'm going to put it here in place of that evaluation. So my first term here my first group becomes h squared minus 2h plus 1 in parentheses. It's just indicating that we're substituting this long expression for all that f of -1 plus h. So the outcome for that, the output for that is all here. Now the setup says minus. I am going to minus. What do we subtract? We're going to minus 1. 1 was that outcome. 1 was that outcome from f of -1. So now I'm going to put 1 here, and once again there's a parentheses around that, and I am going to put an h in the denominator. And so now I have successfully substituted values into my f of -1 plus h minus f of -1 over h into this. So now this is for a long far future from now. But one day when you get comfortable with doing all this work right here, these two steps are usually can skipped when you get some more experience and become faster in terms of doing this work. Then these steps can be skipped, and usually for experienced students, then they can just go directly from where the setup begins, and then immediately substituting in all this here, and then that's gonna start working. All right, and so now in my next step, I'm going to consequently end up with, once again, similar to the earlier problem that we practiced. Then I am now going to remove the parentheses here. Since there was no negative sign in front of my parentheses there, I am going to remove without changing any signs inside of my parentheses. So my first set of parentheses now is gonna, after removing it, it's gonna produce for me h squared minus 2h plus 1 and minus 1, and then after removing the other pairs of parentheses. And so now I'm gonna put h in the denominator, and then once again I'm gonna recognize that there are these two, +1 and -1, being opposite terms. They are to be cancelled away. And once again, we consequently came up with, so in my next step down, I'm going to end up with h squared minus 2h over h. And so in the numerator, there are no further like terms to combine. There are no further opposite terms to cancel. So what you can do now is, but at least you recognize there are a common factor. There is a common factor throughout the two terms in my numerator. And so algebra allows you to factor out the common factor in the numerator. So I would now have h outside of parentheses. And then here we're looking at h minus 2 left behind inside of my parentheses. So what it says here is we have h times, in parentheses, h minus 2. So these two are now factors, and divide by a lonely factor h in the denominator. And so at this point, once again we recognize further that we have two common factor h here. So algebra says you can cancel the two common factors here, and then that gives me a left behind expression here being h minus 2 and over 1. Now I could have mentioned this in my previous example, that anytime you cancel away a common factor from numerator and denominator, your resulting ones, if your factor was a lonely one in a denominator, then your resulting factor would always be a 1, not a 0. And then h minus 2 over 1 is obviously h minus 2. And so concluding our next example here, what we've had here was f of -1 plus h minus f of -1 over h, and we came down to the final answer after all that simplification work was all that there was equals h minus 2. And that is our answer after simplifying the set of f of minus 1 plus h minus f of negative 1 over h. And now let's look back into what we did throughout the two quick little examples right here. But the first one we did, still on the same function, f of x equals x squared. What we did earlier was we came up with we were given a setup f of 1 plus h minus f of 1 over h. Our work here, we don't need to repeat the work, but let's just look at our conclusion. But our work here came down to that final answer, that simplified final answer being h plus 2. The next one that we did was f of negative 1 plus h minus f of negative 1 over h. We've got our answer for this problem being h minus 2. The answers to these problems at this point is not really my main intention, but I need to point out one thing for everybody to have a look at. But I purposely put the two setups here all together, and let's recognize what they have in common. Now, what they have in common is both of these setups right here have the denominator that's look common, h, and they always gonna have, say the first one here have a setup being 1 plus h, f of 1 plus h minus f of 1. So look at that repeated element here that I underlined with my red ink right here. So the f of 1 plus h minus f of 1. And so that similar thing was done again in the next problem down here, f of negative 1. Just simply I switched from a value 1 down to a negative 1. But the exact same setup happened here, f of negative 1 plus h minus f of negative 1 over h. So in other words, really, the two problems we did here really was one setup. That one setup was the previous function, the previously given function, evaluated at some given value a plus h, and then minus the function at a again, and we're dividing that by h. So this is what we recognize the general setup of throughout the two problems we did previously. So here's your a. In this earlier example, your a was 1. In the one we just finished, your a was negative 1. And these were the two final outputs, the two final simplified answers to your two different setups. And so now that setup there, now we have a name for that. We call this setup here, we call that, it's the difference. The difference quotient. It's the difference quotient. Because what it has here, what it has in this setup was there's a difference in the numerator. And then there's denominator is divided by an h. And it's a quotient, it's a fraction. There's numerator and there's denominator. That's why it's together, it's called a difference quotient. And then in particular, it was a different quotient at the given value x equals a. So what it meant by what it means by at x equals a is that we can apply this general setup, a difference quotient at different given x value. So in my starting example right here, That example there was the difference quotient at x equals 1. In the next example that we already did, this example here was nothing but the name, the difference quotient at x equals -2. I apologize. At x equals -1. And so generally speaking, that setup, f of a plus h minus f of a over h, is called the difference quotient at x equals a.